Hi everyone, this is Lesson 8, Video 2, Behaviour of Charged Particles. In this video, I want to provide you with a few examples of static electricity at play, perhaps with a couple of explanations as well, so that you can perhaps try them in our classes during the week. Okay, one of the simplest examples of static electricity that you can demonstrate in the classroom is picking up little pieces of paper with a statically charged balloon. So here we have some little pieces of paper. I've scattered them around the table, just trying to thin them out a little bit so they're not sitting on top of each other. Now I'm going to go and take myself a balloon. Here's one I presented earlier, and I'm going to rub the balloon in my hair. The balloon is made up of plastic. It's a synthetic material. I'm rubbing it against the hair, which is a natural fiber. I like to believe it's a natural fiber. It's not a toupee yet. And we see the balloon becomes charged and a field is created between the balloons and little pieces of paper. And as a result, little pieces of paper experience a force. They leap up to the balloon. In our first video, we talked about electrically induced dipoles. So the balloon is definitely charged. The little pieces of paper are not charged, and yet in the presence of the electric field created by the balloon, the delocalized electrons within the pieces of paper are able to reorganize themselves such that one side of a piece of paper would become positive, one side would become negative. The balloon itself is negative, and it attracts the slightly positive dipole of these little pieces of paper, and they're able to leap up off the table. Here's a slightly different angle on that, so you can actually see the tiny little shards of paper jumping up off the table. There they go. I reckon that's about 1 centimetre or 2. That's definitely a non-contact force being exerted due to an electric field present in the room. Here's an electroscope. My charged pen comes towards the electroscope, going near to the cap but not touching it. The electroscope moves, indicating that the pen is charged, creating a dipole across the electroscope. If I were to touch the cap, then I would be passing charge to the cap. When I remove my pen, the electroscope is no longer a dipole charge, it's actually got a net charge on it. And so we see that the electroscope stays in an excited state until we remove that charge with the fingers. This simulation illustrates what's happening to the charges inside of the electroscope. We bring the negatively charged pen close to the electroscope, and we see that the negative charged delocalized electrons are moving away from the charged pen, creating a dipole across the electroscope. We remove the pen, the dipole disappears, as the charges are again evenly distributed. Bringing our finger in towards the cap of the electroscope, we provide an avenue for the negatively charged delocalized electrons to escape from the electroscope altogether. We remove our finger, we remove the proximity of the charged pen, and we're left with a net charge on the electroscope, which again shows an excited state within the electroscope. Bring the finger back. That allows charge to pass from the earth back to the electroscope, and it's neutral again. There are lots of ways to demonstrate static electricity. This is the last one for this video. We see a tap running into a sink. I've charged up a balloon, and what do you notice? Another example of a dipole being created across the particles within the stream of water. The attractive force between the balloon and the positive side of those dipoles is dragging the water towards the balloon. Well, that's the end of the video, so what now? Take a moment to jot down ideas from this video in your physics notebook. Read and take notes on chapter 5.1 of the Pearson Physics text. Complete all the exercises from chapter 5.1. Complete the Exploring Physics Problem Set 9 exercises, charges and fields. And make sure that you personally have a go at all of these little demonstrations in class of static electricity, as well as the online simulations demonstrating static electricity that I've placed in our sector lesson. I hope this lesson was useful.